Hello everyone, welcome back to JDCodebase. Today is day 14 of our LeetCode 75 series, and today problem is the maximum average subarray 1 and LeetCode number 643. Let's read the problem statement. You are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer within a calculation error less than 10 raised to power minus 5 will be accepted. So let me simplify this for you. We are given an array nums. This, if you see example number 1, we are given an array nums having elements, n elements here, and these are the number format like 1, 12, minus 5, minus 6, 50, and 3. Also, we have an integer k. This integer value may be like 1, 2, 3 up to if you see this 10 raised to power 5. So we have to calculate this maximum average of any subarray of size. Now, what is the subarray? This one is the array 1, 12, minus 5, minus 6, 50, and 3. Subarray is like I just take these three things 1, 12, minus 5. I just take these minus 12, minus 5, minus 6, 50. These are the subarrays type. So I have to calculate the average of these numbers, so and return the maximum average of these. Now how to do this? Like if I have this, let me take this one here. I have this array 1, 12, minus 5, minus 6, 50, and 3, and k is equal to 4, as you know. Subarray is like I have 1, 12, minus 5, minus 6. These are the subarray. Then 12, minus 5, minus 6, and 50. And last is the minus 5, minus 6, and 50, and 3. These three are the possible subarrays of that built from this this complete array in the pair of the 4. Means why 4? Because here k is equal to 4. We have to take this as a length of subarray whose length is equal to k. It's clearly mentioned, and we calculate the average of each number, each subarray. Means we have to calculate 1 plus 12 minus 6 minus 5 and calculate its average based on that. And then 12 minus 5 minus 6 50, then minus 5 minus 6, 50, and 3, and we have to return the maximum one. Now there are the two approaches for this. First one is the brute force approach. You start a for loop like if I write here for let I equal to 0, I smaller than nums dot length and I plus plus, and inside this again start a for loop that's let j equal to I and j is smaller than k and j plus plus, and calculate the sum until till the kth element. So this one is fine, means check every subarray of size k, calculate sum every time, but this will take the time complexity big of n multiply k. That is too slow for this type of solution. Yes, this is too slow. So how to solve this? In this, from this question, from this problem statement, we need a we are introducing a new concept, that is a sliding window. Instead of recalculating sum every time, we keep a window of size k and update the sum by removing left element, adding the new right element. Now this concept, this sliding window concept, is the most important in as for the interview perspective, and every company asks about the sliding window for the optimization. Yes, means it reduces the time complexity from big of n multiply k to big of n. So how to do this? First, calculate the sum of first k element. Like I write here the this one. This first key element is this. The first key element is this. So first calculate the sum then store is as the maximum sum, and start sliding means remove the old element, add the new element, keep updating the maximum sum, and at the end return the maximum sum. So let me write the code for you so you can easily understand what I am saying. Let sum is equal to 0. Just initialize the sum is equal to 0. Start a for loop. Let I equal to 0, I smaller than k, I plus plus. And after that, sum is equal to sum plus nums of I. So I just calculate the sum of array up to the kth length of this. So I just get the k sum based means up to the k length. First window is this, and window size here is the k is equal to 4, up means up to the k value, k is equal to 1 means it is always equal to the n value, num stored length. So don't worry, it does not exceed your out of the bound of the array. Then let maximum sum is equal to sum, and start a for loop. Let I equal to k, and I is smaller than nums dot length, I plus plus. Now why I write here I is equal to k? Because here I already see the from 0 to kth element, means I just cover this 0, 1, 2, 3 up to the 4, means 3 is the up to the 3rd index I just cover. Then start with the further, means 4, 5, 6, 7, 8 up to the num stored length. Now this time sum is equal to sum minus nums of I minus k. Remove the old element, the first element of the subarray, and add the latest element, nums of I, and always update the maximum sum by math.max the maximum sum or the sum, and in last return the maximum sum divided by k. So I get the average as expected. So let me run the code. Yes, it accepted. Let's try to submit the solution. And yes, it passed all the 128 test cases. So here the code is like, let me again one more time I will explain you. First I initialize the sum with the value, initial value is 0. Then I calculate the sum of the subarray up to the kth length, start from the 0th index and go until the up to the kth value. Here k value is 1, 2, 3. I have no idea up to the nums k value, and calculate sum plus nums of I. Then I make a new variable that store the maximum value, maximum sum every time, and start a for loop. Here I start with let I is equal to k. I is always smaller than nums dot length and I plus plus. Why I write here k? Because up to the kth element I already calculated the sum. So now start with the I is equal to k, and it runs till the nums dot length. Now this calculation, this 16th line calculation, I highlight this. This one is the most important line here. Sum is equal to sum minus nums of I minus k, that is the remove the old element, the first element of the subarray, the previous subarray, and add the new element by using this nums of I. And this makes it's big of one update and time complexity update, and the every time I calculate the sum, just compare compare the value with the maximum sum and store the maximum value here, and in last return the maximum sum divided by k, so I get the average Here time complexity is the big of n because I just start a single for row from I is equal to 0 to num float length, and space complexity is the bigger one because I'm not using any extra array or map or any space. Now what you learn from this problem? Sliding window pattern, yes. And in the upcoming videos, the like if I show you this one, yeah, see these next sliding, this is a sliding window part, and in the next three more questions are here, the problems are here based on the sliding window. So I am saying so practice these sliding window about this and how to optimize this from big of n multiply k to the big of n time complexity, and avoid unnecessary recalculation because here I just means calculate some single time. So if you found this video helpful, like the video, comment if you have any doubt, and subscribe to JDCodebase for daily LeetCode content. I will see you in the next video.